Kevin. Thank you much for having me. I'm super excited to be back to dotnetsheff. And thank you everybody for joining and trying to giving me the opportunity to share some of my knowledge that I gained about null and void in .NET. So my name is Stefan Pertz. I like to write clean C# code and do test-driven .NET development. I started to code in 2008. I started with C++ and Java. Then my first line of C# I wrote in 2012. That was together with Unity. So I was using Mono without being aware that I was using Mono. Then .NET, or by that time still .NET Framework, I started in 2013. And then somewhere along that line, I became null-aware, probably around when .NET Core 3.0 together with C#8 was released, because then the nullable reference type has been a big feature, and we will talk about this today a lot. Currently, I'm in Vienna, a senior developer in Admiral Sportwetten. I listed here some of my alter egos in the web. I'm also hanging out in the Slack channel, but I will come back to that at the end if you have some follow-up questions or more detailed question. So what's on the agenda for tonight? First, let's start with what is void, and then everything else will be about null. So we will have a look at nullable reference types and also nullable value types. There is a significant difference, and we will figure that out and what the implications are. We will then see with the new C#8 feature, the nullable reference types feature, what nullable contexts are and how this looks in metadata, which is reflection. We will have a very brief look how this looks in code analysis, which is Roslyn. And then we're gonna dive deep on how this static flow analysis, how this works and what it can do for us, and how the null checks basically work together with this feature. Generic definitions and constraints, again, tied to the to the foundational difference between nullable reference types and nullable value types, are always very interesting to be aware of. Then we're going to inspect some of nullable attributes, which help the compiler figure out to reason about nullability. We will lose a few words about how we could adopt this feature for already existing already existing projects. And we will inspect some alternatives. The null object pattern, which consciously or unconsciously pretty much everybody has used, I'm sure. And we will also have a look at optional types. I believe there is a break in between, and we will have also a look at the questions in the chat. So let's get started. What is void? Void denotes that either a method or a local function returns nothing. Or it could also be a pointer to some unknown type. There is actually, void is actually represented in the BCL. We can have a look at the source code, and there it is. It's actually there. It's a struct, void. It's public, yet it's unspeakable. We cannot actually refer to it as code. We can only use the C# void keyword for that. So to point this out, I have a brief example. So I have here a C#8 record type, which is a class which synthesizes a lot of additional code, such as the properties that I declare here in the positional primary constructor, and also a deconstruct method. And a deconstruct method is a method which returns void, but takes a couple of out parameters. And via reflection, I get the type of this record. I will get the method, the deconstruct method, and have a look at it, what this method's return type is. And it indeed is void. We see at the side, the test passes. We cannot write system.void. Compiler will say, this is unspeakable. We cannot use it. So building this would fail. We need to say, but we can say type of void in order to test, in this case, if the return type of the deconstruct method, of the synthesized deconstruct method, is indeed void. So that's pretty much it about void. Now let's jump to null. What is null? So in C#, the null keyword is the null reference points to nothing. So there is no object referenced. So if we try to dereference it, we will end up with the nasty null reference exception because there is nothing we can dereference. So in this example, if I would run this code, we will get the length of the text, which is 4. If I would set this to null, we would get exactly here the null reference exception because we cannot dereference null. So this is how null works with reference types. Null also works with value types. But this is very important. A nullable value type is different than a non-nullable value type. So all I can add, for example, to make this nullable, so a value type can never be null. It always has a value. So I can't do this. This would not compile. But I could add a question mark here. So now this is no longer a regular value type. It's now a nullable value type, nullable of int in that case. And this can be set to null. But the compiler now actually changes this because a value type always has to be something. It's not a reference type. And it is then wrapped in the system nullable of t. So actually, we now have a different type than we originally had. And if I would go to SharpLab, it's here, and paste this code in, we see that this is now actually a nullable of int. So it's a whole different type. And we need to be aware of that. So what's nullable of t? Nullable of t, again, is a struct, which is constrained that the t only contains structs. But still, it cannot be null. It can never, it's a struct, it cannot be null. So if I would, go to a command line application and try to say, let's toString this in that case. So I try to toString this null. This would now oops, sorry, I made a mistake. I meant to get the value of it, sorry, because so this is now wrapped, so it's no longer a, so this would work if it's just an int, but since it's now nullable of int, in order to access this wrapped value, which is within the nullable of t, we can say value. But if I would try to toString this one now, or if I would try to access value in the first place, although it's null, we will not get a null reference exception because a value type can never be null, but instead we will see we get a, when it pops up, we get an invalid operation exception. And this is because that's how it's implemented in the nullable of t, where the value property, if there is no value, if the value has never been set, then it will throw the invalid operation exception. But the value itself technically would still be the default value of 0 because a struct can never be null. And so therefore there's a foundational difference between an int and an int question mark. Now let's dive into nullable reference types. So now since C#8, we can also add a question mark to a reference type. So we can write, for example, string question mark. Now, what does this mean? So for a value type, that's a whole different type at compile time, or also at runtime. That technically means something different. But with a nullable reference types, it's, under air quotes, just a compiler annotation. So at runtime, it is still the very string that we defined. It's not some other wrapped type of the string, but the compiler adds additional metadata to that. So a nullable reference types has more or less only meaning to the compiler. And we also need to be in a nullable context. So if I briefly add this code here, I now enable the nullable context. Per default, it is disabled depending on the project settings. Since the .NET 6 SDK, the templates have changed, and there it's enabled by default. So in that case, but we can still explicitly enable it. And now I have here a null oblivious type. So this type has not been compiled with nullability in mind. So this was before C# 8 has arisen and compiled, or this library or this piece of code doesn't use the nullable reference feature because it can be opted out of or not being enabled in the first place. So if we would call now this method, we're about to end up with a null reference exception. Exactly here. Here we try to dereference null. Run it once, yes. So there it is. We have the null reference exception. So now then, but we are in a nullable context. So why doesn't the compiler give any warning? Because both sides, both the type itself and the consumer of this type need to be in a nullable context. So if I change to a type which actually was built with nullability in mind, in that case I call it the null aware type. It's the very same type. It also has a text, which I try to dereference here. And now I get a warning. I hope that the contrast is all right. I highlighted the compiler here, spits out a warning. If I have it, we see that we get the warning dereference of a possibly null reference. So this is now a warning from the C# 8 feature nullable reference types. So I now know already at compile time that this here may throw. It doesn't say it really has to throw, but it may throw. So if I would ensure to the compiler that this is set before, so let me set to something here. Not a warning. There is no warning anymore. We just see we see there is no warning. It's all cool. And if I run this, of course, this will print out the 11 characters that the string .NETCHEF has. So nullable reference types are a compiler feature. They can spit out warnings. We can also enable these warnings as errors if we want, which give us a hint at compile time that something may throw at runtime. But at runtime, this is still the very same string. So there's a compile time feature. At runtime, it's still the very same than the non-nullable string. Now there is different terms when it comes to nullability. So something can either be non-nullable. This would be now the new default when we just declare a string. So if I write just a string, this is now a non-nullable string. Then there is the term nullable, very similar to the nullable value type. String question mark is the nullable reference type. We can be oblivious. I hinted this already, when something was not built with the feature enabled. And we could also be unknown in some certain generic scenarios. In this presentation, I also link the official documentation if you want to dive deeper into that topic. So I mentioned nullable contexts. So with nullable contexts, we can control how the compiler considers nullability. Now there's two different sorts. We can either control the warnings or we can control the annotations. And we need both sides in order to produce meaningful warnings. So the annotations, we need to annotate a type with nullability. So we either declare non-nullable or nullable reference types. And the consuming part then may emit warnings if we try to dereference a nullable reference type, but the compiler is not 100% sure that this is actually set to something and it is not null in this flow. So we can control those individually from each other, or when we say enable, we enable both, or when we say disable, which is the default, we have neither. It is still the default with .NET 6, but the .NET 6 templates now have exactly this. I believe in every template, console apps, libraries, ASP.NET Core templates, they now by default have the implicit usings enabled, but also the nullable enable. And this enables both the warnings and the annotations in the entire project. So we could also write here, instead of the enable, we could say, okay, I only want warnings in this project, or I only want to emit annotations. We can also do this in a directory.build.props file, for example, in the root of the repository, so that every file in this, every project in this repository or in this solution has nullable reference types enabled. And the language version must be at least C#8 or higher. We would get, if we try to use it with a lower version, we will get the warning that, or an error, that this feature is not available yet. And additionally, on a project level, we can control the nullable context more fine-grained on a source file level. So in a source file level, we can say with the preprocessor directive nullable, we can enable both annotations or warnings, or enable just the warnings, enable just the annotations, or disable them. And if we write nullable restore, it will restore whatever was defined in the project. So for example, if we have nullable annotations in the project, the nullable restore would be the same as if we would write nullable annotations. And we can have these in the multiple times in a source file. So we could, for each section, control nullability. So let's show this live. Oops, this must actually go. So we have a class which defines a non-nullable string. I call it required text, and a nullable string. I call it optional. And since we are now in a nullable enabled context, we both have annotations enabled. So those properties are now considering annotations. And we also have warnings enabled. This is why I hope the contrast shows it. I will highlight it. We have a warning here and a warning here. So in this warning, in the above warning, we say again, dereference of a possibly null reference, because the compiler at this line of code is not sure if this is really, really null. It's declared as none, it's declared as nullable, and there is no definite assignment beforehand. But with the required text, the compiler knows there is no warning up here. However, we get now warning at the type as well, because it says the non-nullable property, required text, is uninitialized. So the compiler understands that we declared a non-nullable reference type, but we haven't initialized it to something when we leave the constructor. So we could either now add a constructor, or I just set it here to something. Even an empty string is fine, because it can now be safely dereferenced. And we could control this. So I could say, for example, okay, I want to enable, let's say I only want to have annotations here. So we no longer get, and we will disable the warnings. Disable warnings. So now I only have the annotations here. So up here, I still get the warning up here because the type was compiled with annotations. But the warning that we used to have here, because the constructor leaves without having the non-nullable reference type initialized, this warning is gone, because in this context, or everything starting from here down below, only has the annotations enabled, not the warnings. So this is two parts that can be controlled individually and eventually must play together in order to have the warning at compile time. Now with generated code per default, the nullable context, whatever we defined on a project level, does not apply. So generated code ignores what we set in the CS proj or in the directory.build.props up here. It's always disabled. But we could enable it, of course, and opt in with the nullable preprocessor directive. Just put it on the top of each generated file. What is a generated file? It is either or every file which is in a directory which has an editor config, which contains generated code is true, or what we will see most likely, either a comment at top saying auto-generated, or now with source generators, we will see a lot of .g.cs extensions. So all of these rules declare to the compiler that this is a generated file, and then not every diagnostics of the compiler applies per default, but it can be overridden. So now what does this nullable annotation do if it actually doesn't really change the type like a nullable value type? So actually, let's jump into an example. I declared here in SharpLab a class. We have both nullable annotations and nullable warnings enabled. And I have the first method, method 1, which takes as a parameter a nullable string. And with the compiler now emits two attributes. So those attributes are not in the BCL. They are emitted when we enable nullable annotations. We get the nullable attribute and the nullable context attribute. Nullable context attribute defines some sort of default for that context that can be overridden with the nullable attribute. This will make sense just in a second. So for this class, we will set the nullable context to 1. Now, what does this 1 mean? There is 0, 1, and 2. In this, so this byte says that a 0 is oblivious. That means the compiler doesn't know. It's not compiled with nullability in mind. Or it has some corner case and some generic cases when a compiler isn't sure. It can be 1, which means not annotated. Now this is a bit, when you think about it, so it's not annotated. That means there is no question mark. So that means it is non-nullable. The other way, if it is a 2, it's annotated, which denotes there is something, it's annotated with a question mark. So that's now a nullable reference type. And with that information, we can now see, okay, this default context set to 1, which is non-nullable. And this attribute can be defined multiple times. The compiler tries to emit as little as possible attributes. This is why this context attribute exists in order to reduce the size of the generated assembly. So this is why this context attributes exist. And then the nullable attribute is then to have a more fine-grained selection. So in here, we now set the nullable context to 2, which means that everything that follows now is annotated, so nullable. So this would be a string of question mark. And indeed, this is how we defined it in the source code. But we see that it's still the plain old string. It's just, under air quotes, just some metadata which gets emitted on the members. Now, I'll skip the second example, but for the third example, we have, for example, here an array. Now, an array consists of 2 parts. First, the array type itself. So the array could be nullable, since an array is a reference type. And the element type, in that case, the string, could also be either nullable or non-nullable. So we can have all the combinations. So here we have a nullable array, excuse me, a non-nullable array of non-nullable strings. The second one, we have a nullable array of non-nullable strings. So the array may be null, the strings in there not. The other way around, we have a non-nullable array of nullable strings, and both the element type and the array itself can also be nullable. And if we see down here below, this is how it gets emitted. So since we are in a nullable context of 1, this goes for the entire class. If there is no more specific nullable attribute, this means that it is not annotated, which means it is non-nullable. So we have here the non-nullable string of non-nullable, the non-nullable array of non-nullable strings. And here we now have the combination. So with arrays, or in general with generic types, this nullable can now take also an array, which means that the first thing, the array itself, that's a 2. So the array itself may be nullable. The second element is the element type, 1. So the element string may not be nullable. And this is now how this gets translated. And the compiler, Roslyn, is evaluating those attributes and then reasons about if something can be null or may not be null, and then emits warnings. We can also use this metadata for ourselves. For example, Entity Framework is using it, and if this feature is enabled, it will actually cause a difference at runtime, because Entity Framework analyzes the attributes, and if the feature is enabled, it will then generate, for example, SQL statements, which then has the nullable or not null constraints, depending on how we declared the types in C#. And it's a bit tedious, so you need to be aware of these rules, how this nullable context and the nullable attribute, how they play along, and that the closest one wins. And then, for example, with properties, there is the get, the set, and it becomes very difficult to actually, if we would like to analyze or use these attributes at runtime via reflection. So since .NET 6, there has been a new type added, the nullability info context, and with the nullability, the nullability info. So there is we first need to, we can create a nullability info context that holds and caches data. From that, we can create nullability infos, from which we then can query, for example, from the getter of a property, the nullability state. And if we have a look at the nullability state, we will see again something very, very similar. It's just named differently, that the 0 means unknown, or also oblivious in Roslyn terms. The 1 means not null, or not annotated in Roslyn terms. And the 2 means nullable, not it is annotated. In that case, a question mark. We can use this information and actually, so this very class that we saw, if I run this example, we can, I'm now with this nullable, with this new .NET 6 type, analyzing this class. It's the very same class that we saw in SharpLab. We can see, I basically print it out with a custom formatting. So the first one here, it's a nullable string. So I can say the first argument, it's a nullable string. And also down below, the fourth one, this is a nullable array of nullable strings. So we can literally print it out, the nullable array of nullable strings. And for that, I will just briefly highlight it. We can use nullability info context. So first of all, I will highlight the interesting parts. We have to initialize, where is it? I believe, do I have the wrong example? Sorry. This one. I was at the wrong example. So there we are. Yes. So we can new up the nullability info context, which we can then reuse because it caches. When we throw it away and create a new one, then we lose what was queried before. It internally caches the results. Then, so for this example, from I for each all the methods, get all the parameters. And then eventually we can now, with this context, so we have here the nullability info context, we can say create and pass in that case, the parameter of the method. Now we get the nullability info. And this nullability info contains the type that it reasons about. It has the read state and the write state. For parameters, it's the same. The read state and write state is the same. But for example, for properties, the read state and the write state could be different because of the get and the set. If it is an array, it has the type of this array. And if it's generic, it has an array of the generic type arguments. And each of those now have a nullability state. And that's the type that I shown before. So we now know if this property is, for example, nullable or not nullable. And so with this type, we can easily build, for example, something similar like entity framework if we need at runtime to figure out whether a member or a parameter to a method is declared as nullable or not. So this is how it looks in metadata, which is reflection. I will also want to briefly highlight how this looks in Roslyn. Again, it's very, very similar. So Roslyn has this type nullable context options, which basically now shows the nullable context option shows how it is in the CS_proj or in the .build.props. So what we define, for example, in the nullable property and the nullable annotations that we said we are the nullable preprocessor directive considered with the nullable context where we have all the combinations possible. So only the warnings are enabled, only the annotations are enabled, all are enabled, and so on and so forth. So all the combinations. And there is, from the syntax node, since Roslyn basically builds a syntax tree, there is the nullable type syntax. So let's have a brief look on how this looks in Roslyn. So let's have a look. Let's make it like string. Let's have here the method. I pass in a string, a nullable argument. And we can switch to the syntax tree. So this is how it looks like from a Roslyn point of view. That's the tokenized representation of our code. We have a dart class declaration. There is our method declaration. Now the method declaration has a parameter list. It has one parameter, and this parameter is nullable type, where this nullable type now wraps the element type, which is in that case the string. So it says here identifier name. The identifier name is string. And with that, we can also now build, for example, an analyzer or a code fixer. With Roslyn, which could, for example, highlight us. In this case, I have a data contract, and I always want to use the data member attribute. And the data member attribute has a is required property. And I want to use that. So if the property is of type reference type, then I want to ensure that if the required is true, then this should be a non-nullable reference type. But if the required is false, this should be a nullable reference type. So if I would change this required to a false, we now get a warning from this custom analyzer that I built. I hope the contrast allows it, otherwise I'll highlight it. We get a warning here over the entire property. If I highlight it, we see that the serializable required text is annotated ambiguously. So we say it's not required, but it has to be set of something. So it's a bit of an ambiguity. So this is an analyzer, and we can also build a code fix, which now in that case wraps this string node into the nullable type node. So if I hit Alt-Enter, I can say change nullable. So I now added this new node and now fixed it. So this is no longer required. This is also optional one. So this is how we can use with Roslyn. This is how we can use the C# feature nullable reference types also at compile time and build our own analyzers, code fixes, but also source generators, for example. And this was now a lot of how the nullable reference type features syntax and how it emits metadata or how it's consumed in Roslyn. And after the break, we will dive a bit more into the static flow analysis. So what the compiler does and some interesting parts in generics and nullable attributes.
Cool. Thanks, Stefan. So we're going to take a quick 15-minute break. So we gather at 19:35 in UK time. So feel free to kind of go nip to the loo, grab a drink, whatever else. And as soon as we grab the back, we'll go do the the raffle as well before we get back into the talks. So yeah, and feel free to chat as well if you're still sticking around. And I'll post in the chat as well the link for the raffle as well. So in case you've not already filled it in, so you've still got time to submit. Also, I don't think anybody can unmute themselves. 1 second. There you go. People should be able to unmute themselves now as well to say hi.
And everybody was quiet.
Don't chat too much.
That's it. Well, it's because we've been away, haven't it, for Christmas and stuff, and then took everybody together. They don't know what to say.
Except for how many people got COVID.
I've dodged it still.
I've not had it yet either. Quite impressed.
Had 2 lots of it in my house, but seem to have dodged it. Yeah,
a few people at my work got it just on the last day of working, and then gave it to all their family.
Oh,
yeah.
Which is quite
Happy
fun.
Christmas.
Yeah, it is a present.
That's it.
It's time to calm down a bit now, though.
I don't know. They're still coming down with it at my daughter's school. So.
See, it's kids.
Oh yeah, I lot are as well. There's numerous. We've got it. My youngest is like on lateral flows every day. It's like, oh, I'm sure I'll have it. It's like, no. It says, but I sat next to so and so, and next to them, and next to them, and they've all got it.
Yeah.
It's like, well, you haven't.
Good immune system.
That's it. So no, I dodged it. The only thing I thought was whether I got ill from. Well, David will know because I dropped out of Advent and Code. That was after my booster.
Oh, okay.
It was like 4 days later. But proper can't even be bothered to put the telly on in bed.
Oh no.
That level of ill.
Yeah.
So yeah, hence this slight pause on Advent of Code. But other than that, no, dodging it. Did you go back and complete everything? Oh, sorry.
My manager went away after each of his jabs, had a week off work because it just kills him off. And he's caught COVID twice and had 3 jabs for a week at a time.
Yeah.
how does this work?
Did you finish all the advents in the end, David?
Yeah, I finished all the 2021s, and then still enthusiastic, I went and did all the 2015s as well.
Have you done them all?
Yeah, well, I'm halfway through 2016 now. So.
I'd like to go back and do 2015, but
2015 is easy actually because it's the first
are
one.
they? First ones, they haven't made them hard yet.
No. There's a couple of slightly tricky ones, but nothing like, the hard ones in the later years.
Nothing like that interpreted program.
No.
The advent of cyber. On Try Hack Me, if you've heard of it.
What's I missed that.
There was an advent of cyber as well on tryhackme.com.
Oh, right.
All right.
I did start that, but yeah, it got it's security centric, but it's.
I hadn't seen that one.
No.
The code one's enough. It's when they start about 5 minutes to 10 minutes a day, and then suddenly you do a whole Sunday.
Yeah.
There were just a few in there that were just particularly awkward. The thingy fit, what are they called? I can't remember what they called them. I'm sure it was some snail fish or something. The ones where he had the little strip and they came out of their home and they move. They have to swap round, so they all come in the same order.
Oh yeah. Yes.
That was quite messy. And you get it right and you think, got it. Let's run the actual code. And it's like, that's my computer hung. And then you realise that's it. You realise in your sample, 2 of them were already in the right place.
Yeah.
And by taking those 2 out, you've just created like 100 times more processing that it needs to do.
Yeah.
But that was a bit messy. And the one where it had the pairs and then exploded, you had to explode them if they were 4 deep, because it was just a debugging nightmare because the recursion just couldn't. It's so hard to follow. Don't know. Maybe I'm getting old.
No, a lot of them I end up having the right approach, but just messing up the coding. Yeah, sort of. Because like rushing to get it done before work or cramming it in after work, and then you just end up making silly mistakes, and then you doubt whether your approach is completely wrong. Or
And then there was another. I can't remember which one it was, where you ran it against the sample. It was absolutely fine, and then you ran it against to test the actual proper data, and it comes out with the wrong answer. You think, how could that possibly happen? Yeah. It's done like 500,000 iterations to get to that number. It's like, how can it produce a different number on the real data?
Yes. Yeah.
And then you see that just a little tiny bit of code's wrong. Go on.
I'm just looking at the Try and Hack Me one. They have like loads of prizes. So if you complete even just one of the questions, you enter into the raffle at the end. And you can win like 5 security courses worth $5,000, 4 Asus Zen books. Like there's loads of stuff on there, which is quite cool.
That might be better than Advent of Code, where you give up your whole December and then have nothing to show for it at the end.
For nothing, just a place on a leaderboard, and only a place on your personal leaderboard, because the chance of getting anywhere near the actual leaderboard. Firstly, we don't get up at 5 a.m.
Yeah. Yes.
I think it's just the satisfaction. I just get great satisfaction in just being able to go and say, yeah, I've done it.
Yeah.
And when you come out of one and you think, do you know what, that one was actually quite straightforward.
Yeah.
I think, I'm happy with myself then. I mean, it'd be far more productive writing some actual code, like for work.
Yes.
The satisfaction of getting paid for it.
Probably quicker as well.
Yeah. Yes. But no, it's more satisfying to write something you don't get paid for. I shouldn't even have opened that try hack me page.
It's quite fun. It's a January gun.
That's it.
Still amazes me that the guy who does admin to code is just one single guy, just randomly did it once for the fun of it between like a few friends, and then went viral.
Yeah, it's great because a lot of people do it.
Yeah,
because when you get on some of the hard ones, you think, "Oh, that was hard." How many people manage that? And you find like 40,000 people still walk through it easily. But you wonder how many people actually get to that first page and then give up. So that's the statistic you want. How many people have we actually got logged in?
Yeah, the stats are actually they show you some basic stats on the thing. So,
200,000 people did the first day. Oh yeah, there you go.
19,000. Yeah,
that's 19.
195,000.
195,000 that managed it, but how many started it, created themselves an account, started it, and then gave up because it was too hard?
That's true.
Yeah.
But I'd quite like to know how many people sort of actually kicked off the, as you get some of the really tricky ones, like number 19, where you can see people really tailed off there. What was that one?
At the boxes.
I think you can click on it and then it should tell you what it is. Oh, the beacons and scanners. That was quite tricky.
Yeah, you can see where they go down there. Like, it's like pretty much. Yeah,
there's a dent on 12 as well. Or when you get quite a high second part, like number 8, where 11,000 people didn't complete the second part because it was difficult.
Yeah, that's probably the difficulty, second part, I guess.
Yeah, cool. 33,000. That's quite a lot now. What was that? That must have been that tricky at number 3.
Still quite impressive that like 10,000 people have still completed it.
I can't think what was on the last one for 5,000 people to not get the second part of it.
On day 25?
Yeah.
Yeah, it means you have to have all the other days complete.
Right. Okay. That makes sense.
Look at that, though. The difference. So this is 2021, so last year.
Yeah.
2020 is kind of similar, right? But it's more of a curve. So it looks like it just gets generally harder.
Yeah.
But more people.
2019.
2019 is really hard. Yeah.
Like literally, people only do the first few days and then just die.
But it's interesting on 2021 that more people started it, but didn't fit. You got nearly 200,000 start, but only 10,000 at the end. Yeah, on 2020, less people start it, but you get more people at the end. Yeah. So that was obviously more linear.
And this one, there's only 100,000 people that started this one, but literally it drops down to way less than half. Like
very quickly,
5 days in here. Like obviously the people at the top here were just a lot of Davids.
I don't know. On this now, I'm stuck on day 15 and day 12 on here.
Oh yeah,
yeah, I haven't got past there yet.
15, sure. I might have a go at some point.
I haven't looked at the ones after 15 yet.
Because I ain't got anything better to do. It's the other stats when you bring up the actual the leaderboards.
Oh yeah, that is pretty depressing.
It's just it's or is it per day? I think you have to go onto the actual day, and you go onto like day 1. You think 1 minute and 7 seconds.
Oh, yeah.
It took me more than 1 minute and 7 seconds to sit down and open the web page.
Yeah.
But that's 1 minute, and it's also 1 minute and 7 seconds from when they released it. It's not from when they started.
No. Was that day 19? That's like the hardest one. How fast did the people do that one? Yeah, see, that one's 21 minutes for even.
Yeah, and also as you get, by the time you get to number 50, you're already at a minute. You're already at an hour. So it goes up very quickly.
Yeah. Interesting stats.
Yeah.
I'm going to do the raffle now before we just kick off again. It'll be 35. So I think nobody else has submitted anything else. Oh, yes, they have. So let me just copy them again. So these are all the people who's that's not even filtering. Stupid Google Sheets. Yes. So these are all the people who said they wanted to win a ray gun t-shirt. So I'm going to shuffle them up and spin it. Andrew, well done. And then for the JetBrains license, let's give the people for that. Which is these people. Shuffle these ones up. You won again. It's flute. And then the last one to win a packet book. You selected yes to that as well, but I might take you out of the raffle just in case you win 3 times. I'll leave you in. Probability is pretty low. Very close. Roslyn, oh, it's kind of fixed. There's another Andrew. Just like that. It's Andrew Douglas, wasn't it? The first 2?
Yeah.
Yeah. It's good. I just highlighted took the wrong people. Okay, cool. Let's go back into talk. I'll ping you all the message private. Oh, I've got your email address anyway, so I'll just send you emails for like the links for the Raygun t-shirt. It's just a link where you kind of just enter your own postal address and it gets posted over to you. And the JetBrains and the packet book, I just need to send you a link to get them as well. So I'll get them out to you. But I'll hand it over to Stefan to continue tonight's talk for the next section.
Yeah, thank you. Making sure if I share the correct screen. Yes, I do. Okay, now it's time to see how the static flow analysis works in Roslyn and how it considers Nullcheck so that it helps us displaying warnings at the correct places. So let's consider this example. I have a class which has a non-nullable string property. And I have a constructor where I definitely set it. So this is why we get a warning at this constructor. We have the warning here saying the non-nullable property text is uninitialized when you leave this constructor. So I could, for example, to make sure it's not null, set this here. Text is chef. And now the warning goes away. So we saw this before. And now from the consumer point of view, actually, let me set this to null. So that we see here. Up here, we now here don't have a warning because compiler knows this text is non-nullable, so I don't need to do a null check. So what if we would declare it as nullable? Now the warning in this constructor goes away because it's all right to leave it uninitialized, maybe null. So the warning is now here because we are now dereferencing, trying to dereference the property text, which could be null. So I can basically put this into a null check. I could say if instead.text is not null. Now the compiler knows, okay, in this block, the text property is not null, so it's safe to access it. However, this flow analysis, it's static. So I will actually change it back. No, let's leave it that way. So this flow analysis is static indeed. It's not dynamic. So I have here the method, set, which now sets it to null. So if I would call this method just before, where I know as a reader, this method now sets it to null. So we will have a null reference exception here, but the compiler does not go that deep because this dynamic analysis would be way too costly and would make the editing experience not very nice if you have a lot of code. So this is why it's only static. Another side effect that we could see is it's not thread safe. So this set, maybe it's not called somewhere here, but perhaps since it's a public method, a different thread calls it. And now this could be null, so it's not thread safe and it's not dynamic. Now, if I change this back to non-nullable, but we actually do want to set it nullable. So the warning that we get here, we cannot convert the null literal to a non-nullable reference type. So we cannot assign null to something which is declared as non-nullable. But if I still really, because I know what I do, I write the code, I really want to set it to null, we can use the null forgiving operator, or also sometimes referred to as the dammit operator. So we can say a null exclamation point, and now the warning goes away. Again, this exclamation point, just as the reference, just as the question mark with reference type, it doesn't change anything at runtime. It's just a hint to the compiler. Okay, suppress this warning right here. We could also, I will change this back to be nullable. Now we get the warning. If I remove the null check, we have the warning back here. So we can use the null forgiving operator also here before dereferencing. Now the warning goes away. The static flow analysis also does not ignore conditional compiled methods. So what we could do, we could write debug.assert. For example, I am sure that this text here is not null, so I want to suppress this warning, either with the null forgiving operator, or we could do with a debug assert a null check is not null. Now the warning goes away because we basically checked here for null. Now debug assert has an annotation. We will come to that right away, but or in a couple of minutes. But also if we would compile this in release build, we would still get the warning. So the compiler doesn't ignore conditional methods because this assert, it's actually compiled with the conditional debug. So in release, it's not there. Another interesting thing to note is arrays. So let's say I have an var array, which is a non-nullable array of nullable strings. And let's initialize it with 1. So this array now fits one element. But if I would try to dereference, so I can safely dereference the array. And I can also safely dereference the element in it. What am I doing wrong? Okay, I believe I now totally embarrassed myself. Oh, I do get the warning. Yes, sorry, my bad. I didn't mean, okay, yes, I do get a warning. Sorry. And I also got the error in release mode because I set warnings as errors. Yes, this explains it. But I wanted actually to show, sorry, if we declare this as a non-nullable string. Now, although it's a non-nullable string, we don't get a warning here because arrays, in that case, they are exempt from this rule because I believe it would be too noisy. Some analysis from Microsoft has surfaced. So this will actually, although we have no warning, and we haven't initialized this string to something, we get the classy null reference exception. So the compiler doesn't prevent me to not initialize elements in an array. The compiler also doesn't warn about structs. So if I bring back, let me remove the constructors. So I now have just a non-nullable string property. I get the warning because text is uninitialized. If I change this to a struct, the warning goes away. So structs are also not considered in this nullable flow analysis, or at least the declaration of members in structs. Yes. So this was that example. And now let's go to Nullcheck. So there is plenty of different ways how to Nullcheck. And it seems like every other release of C# adds another method of how we could check for null. So let's here jump into the example of all the null checks possible, which are actually considered by the static flow analysis. So we could, that's like the classic check, we could check for equality. For example, via the .equals method. So we get the warning. Oops, sorry. We get a warning right here because the record that we dereference here may be null because we beforehand tested that it is null, and in this block, the compiler says record may be null. So it gives warning when you dereference it. If I invert that, not a warning, basically move down because it's now inverted. So the top block says now here, record is not null, but in the second block, it may be null. We can also check by identity, which is basically if something is of type object. So we could cast to object, and then to a null check. It's the same thing. So I have the warning here because I'm here in a null. The static flow analysis said that in this block, record may be null. And if I say not null, then the warning moves down to the other block. We can also use equality comparers to check for null. So here I check that this record instance is null. This is why I get a warning here. We can also check with a null conditional operators, which is a question mark before we dereference something, or a question mark before we index into an array. There is also the null coalescing operator. So via question mark, we can say if the left-hand operation is null, 1, or return the result of the right-hand operation. So record is null here, and after this line, record is no longer null. We can indeed check for it. It's not null. But up here, oops. But of course up here, it should be null. We can also check with pattern matching. Was actually added in C#8. Oh, I may now confuse the language versions. Or is it C#9? Okay, I'm now confusing it. But since rather recently, previously we could check for is null, but is not null was not possible. So we can now check for is not null. And there is now some interesting part about how we can test for null. So if we do it via the equality operator, this is actually not necessarily a true null check. We see here, I have here the red, so I have a test here which actually fails. But what does this test fail with? It fails with a system not implemented exception. So this unequal operator, the inequality operator, is not implemented. So if we use either the equality operator or the inequality operator, or if we use some overloads of the equals method, or using some implementation of an equality comparer, like down here, the implementation could do something wrong. So this is not a pure null check. We must hope, and pretty much, yes, every type in the BCL is definitely implemented correctly, that if we check for null, it will return the correct answer to the question whether it is null or not. But for example, I could make, in my custom types, I could make an error. Like here, I did not implement this inequality check. Actually didn't implement anything. So this is actually more than a null check, because we will actually call into a method, which then hopefully eventually somewhere checks for null. This is how most equals, overrides, or equality operators are implemented. Well, the equality operator most likely calls into the equals override. So it has a logical implication, but we could. So what is now a pure null check? If I scroll down here, I use the very same thing. I use this very same class, but all those tests now, here we are all green. So this all passes, because although we use the inequality operator and again the equals overrides, but we don't call into the overrides of this class. We use something like a pure null check. So we cast this to object, and on object, the equality operator on object does a pure null check. If we are object.equals, for example, this is in a true null check. Or in that case, if we use, there is a reference equality comparer, this one also eventually does a null check, a correct null check. So how does this look like in you can see how this looks like in IL. So if we compile this, open the IL viewer, we see that here, let me make this a little bit bigger. Yes, is it up here? Where is it? I was hoping it highlights the code for me. I am admitting I am not the most fluent in IL. Not sure why the highlighting currently doesn't work. But okay, I'm not really in this, but we would see. Will I find it briefly? Let me just check. Where is it? Let's actually, I think yes, there it is. This is what I wanted to show. Sorry for the confusion. Here we see that when we call the inequality operator, that we actually do overload. We see in IL also that this inequality operator is invoked. If we check this now, for example, something like pattern matching is not null, and we build it. And then have a look at the IL again. Hope it highlights it for me, otherwise I will briefly scroll to it. Quality. So 1, 2, 3 should be here. And we see here that, do we? I'm not sure. I'm afraid I'm not entirely sure what I'm doing wrong, or perhaps we see it, but I currently don't see it right now. But we would see that, I was hoping to see that there is no invocation of any method or any operator. So this indeed does, from an IL perspective, also a pure null check. And this also now has a bit of a tiny performance implication. So I did with benchmark.net a couple of benchmarks. For example, here, compared some different variations of checking for null. So I have a record type. Again, a record type emits a lot of methods, the deconstruct method, but it also emits an equality or an equals overload. And it also emits inequality and equality operators. So we see that now with the equality operator being overloaded, we see a bit of a difference. So this is 0.22 nanoseconds. And we see a bit of a difference to something which is a pure null check, which doesn't call in any method. For example, if we cast it to object before, or if we use pattern matching, such as the is null, then we see there is nothing really measurable in there. So these are, the compiler understands these as pure null checks. Also, if we use the reference equality comparer and check for null. So the reference equality comparer, check for null. And we see also here, this is not really measurable. But if we use something which actually calls into a method which is implemented, like the equality operator or the equals method eventually, then we get some measurable results. So, okay, so those performance difference is somewhat neglectable, but it again highlights that there is a difference between a pure null check or a null check which calls into a method, which then eventually, hopefully, the implementation checks somewhere for null. So that's about null checks. Now let's come to the generic definitions and constraints. What's very important to keep in mind with generics is the foundational difference between nullable value types and nullable reference types. Because a nullable value type can never be null. It's just, under air quotes, just translated to a different type. It's at runtime a whole new different type. It now becomes nullable of T, which wraps, in that case, the T and offers it in the value property of that struct. But with reference types, it's just a metadata addition. So a string keeps being a string with some attributes on top of it. So we need to keep that in mind with the generic constraints. And let's jump to this example. So we can have something very classy, unconstrained. If we just write something, we have here one generic type parameter. So it's unconstrained. I can pass anything without getting a warning. I can pass in an integer or a nullable integer. I can pass in a string or a nullable string. So we don't get any warning here. Now there is the not null constraint. We can say, since C#8, where T is not null. And now it allows both either a non-nullable value type, in this case int, or a non-nullable reference type. So we get no warning here. Well, we get it down here because the method doesn't fit, the type doesn't fit anymore, but there is no warning at the declaration. But if I would write a nullable reference type, here you get the warning. And it says explicitly, nullability of type argument string must match the not null constraint. And this also passes through two overloads. Not overloads, but overrides. So if we derive from a class which declares a method, and this method declares a type parameter which has the not null constraint. Now that overridden method also must declare the not null constraint. Otherwise, we would get a warning because now these definitions don't really match anymore. And the same if I say int question mark, so a nullable of T, we get a warning here. Basically the same warning. But again, it says here, it's a system nullable of int. So the compiler understands this special casing that's a whole new different type. there is also, how can we declare if I want to, previously if we wanted to have something of a reference type, we can say class. And now in C# 8, if we enable the features, that's still the same. So if I write where T of class, so any reference type, this now means that it is a non-nullable reference type. So I can't write a string question mark without getting the warning here. But we can also say, we can also annotate this constraint. We can say where T is class question mark. So now nullable are allowed. This doesn't mean that non-nullable is non-allowed, but so we actually still, we now get the warning here because this method that we declare, the T, now is not nullable. So the compiler understands null here is not valid, but at the definition, it's fine. And we can also, well, we could previously state that something may be a struct. So we can say, we can constrain it to struct. And that means always it's a non-nullable struct because of the foundational difference of the type. If you would have a generic type definition declaring it to struct and now writing int question mark, this actually is a compiler error still. It's the nullable of T. So in the generic type, we would need to refer this to the value with saying instance.value. And since it's not compatible, this still does not work. Now let's jump to an example. Let's have a look at this dictionary. So for dictionaries, the implementation, if we try to add a null value as a key, it would throw an exception. It's not allowed. And since with the latest BCL, this is now annotated as such, it says where T is not null. So I can't, for example, say here a nullable of int or neither a nullable of string and nullable reference types. We get the warning that it must match the not null constraint. But the value may be null. That's fine. So we don't get a warning here. It's unconstrained. So that's about generics. Now, I mentioned this previously before with the debug.assert. There's a whole bunch of nullable attributes. And they have been added in .NET Core 3.0, also in .NET Standard 2.1, and even more types have been added in .NET 5. With nullable attributes in .NET 6, there have been no addition because this set is, seems pretty complete to annotate all the most common scenarios. So let's have a look at these. So I will not have a look at all of them right now. They're all very well documented. Let's have a look at 3 or 4 of them. So for example, there is the allow null. Let me remove that for now. Now we get warnings here because we have here declared a non-nullable string. We are in a nullable context, so this is why annotations are emitted and warnings are produced. And if we try to set it to null, we get a warning. But also, now the compiler understands, hey, this text here, we set it previously to null, so this is why we get the warning here. If I would remove this, now the compiler with the static analysis can't really say if it is null, it is declared as not nullable, so this is why there is no warning here. If I add this back, there was a warning because the compiler sees it's null. But we get a warning here because it shouldn't be. But in the code that I have here, I actually kind of allow null because in the setter, if we are the null conditional operator, so if the value here that we pass is null, then we use string.empty. But yeah, so that the compiler in static flow analysis, it doesn't really check that, but we can help the compiler to annotate this scenario via the allow null attribute. And now the warning here goes away because we tell the compiler, okay, it's fine when we try to set it to null, some sort of precondition, null is allowed. So that's cool. But we must be careful. We could lie to the compiler. So if I would, let's say I could like still assign null here, then add an exclamation point to suppress the warning. Now we still don't get a warning here because we kind of lied to the compiler now. So this attributes the compiler is strictly observing. This also goes into the another direction. So in this example, now we here can set it to null because that's a nullable string. It's fine. But if we would try to set it, we would actually throw an argument null exception. So this is for a scenario where we would some sort of declare if something has never been set, but we do not allow setting it explicitly to null. So we could annotate that with the disallow null attribute. So this is now, when I enable this attribute here, I now get a warning here, although the property has been defined as nullable. And now the consumer of this, for example, library knows, okay, although this is set to non-nullable, there is something wrong. So in that case, the implementation would actually throw. So this warning here should be emitted. Now there's plenty more which have been added to show various scenarios in .NET Core 3 and Net Standard 2.0. I want to jump to a later example of Net 5. In that case, the member not null. Let's jump to this. This is a little bit simpler. So let's say I have a scenario where I have as a member a non-nullable string, and I do not set it in the constructor directly. If I would set it in the constructor and assign the message here, the warning goes away, that's fine. But the compiler doesn't jump into this initialize method. I set it actually in the initialize method here, but the compiler doesn't go that deep for this on this level. So I can annotate it with the member not null attribute, which basically tells the compiler if this method is invoked, then this member is not null anymore. And now the warning goes away. But again, we must be careful because I could lie to the compiler and still not assign it. But we have no warning here. So, okay, we do have a warning here, but it's a different warning. That's not a nullable warning. That's a warning that this value is never assigned. So it's basically always null. So that's a different diagnostic. It's not a nullable analysis warning. And I also showed the dictionary example. But dictionary has another annotation. So the try get value is also annotated. So in this example, try get value is very highly used together with dictionary. So in this example, I have here the if method, and the try get value returns the value with this key into this out and returns a Boolean whether it has been found or not. And now the nullable analysis figures out that, okay, it is safe to dereference this value in this context, but it's not safe here. We have the warning here because here it may be null. We get the nullable warning here because the try get value is annotated with the maybe null when attribute. Can I scroll? Oh, let me actually put it like this. The maybe null attribute. So we have here the t. We saw previously that the t of value is unconstrained, so it could be anything. And I declare this dictionary, the key is string, non-nullable, and the value is also string, not nullable. But now I kind of override this not nullable string via the maybe null when attribute, which says, hey, if this method returns false, then this may be null. And this is why I then have to add the string question mark. Although it hasn't been annotated here, I need to add it here. If I don't have it, compiler says, okay, there was something wrong. And with that, we can now say, okay, it's safe to dereference it here. It is not null, just that it has been declared here. But if we are in the else block, if this method returns false, which we are in here, it may be null. So the compiler knows, okay, here could be an issue. Another annotation that I showed previously, do I still have it here? Let's reconstruct the example. Let's declare a nullable string. Try to dereference it. Oops. Text.length. Of course, we get a warning here, but we could say debug.assert text is not null. Now the warning goes away because the debug assert is also annotated with that does not return if annotation. So that does not return if annotation says now if this condition that we pass here is false or is evaluated to false, then this method doesn't return, which means it throws. So everything that happens afterwards will not be executed. Well, this is only true for debug because in release, this method is discarded, but still the nullable annotation context does not discard conditional methods. So this is how this works with the does not return if attribute. This is also used in the latest edition. I haven't linked it yet to this presentation. I shall do so afterwards. If we go to source.net, with .NET 6, the argument null exception now has a new throw if null method. There it is. And this throw if null method is also now annotated. It says, oh, actually, that's the pointer method. Sorry, let's go to the object method. Yeah, it says it has the not null attribute on it, which says basically after this method has been invocated, whatever was passed here is not null anymore because it actually eventually, we see it here, it throws an exception. Now again, this is annotated with does not return. So the static flow analysis is aware that if this method is invoked, everything else which comes afterwards doesn't need to be analyzed because we throw here. And so this is how we can do also null checks at the top or somewhere. And then after the throw if null method has been invocated, we know that the argument is not null anymore because it has been annotated with that. And there's a bunch of more nullable attributes that I linked in the presentation. You can check out this documentation page. They're all listed and with examples on how to annotate your library to make it very nicely consumable when it comes to nullable reference types for your consumer. Now, if you have an existing project, how could we get started with nullable reference types? Since the default still with .NET 6 and C#10, by default, it's enabled. It must be explicitly be enabled. So one strategy could be that we first enable it on a project level. And then in the next step, there will be a lot, if it's a huge project, there will be a lot of nullable warnings everywhere. So we could then go to each and every file, perhaps via a script, and add the nullable disable. And then every time we modify a file, we change something, we add something, remove something, we could have a look at the nullable warnings. We could remove now this nullable disable on the top of this one file and start fixing the warnings and properly annotating it via a question mark or some more nullable attributes to tell the compiler to make those types annotated, and then later on for the consumer then can actually produce warnings out of that. And then at the very, very end, when we have removed each and every nullable disable, that means that we're done. Now it is fully annotated. And the benefit of this strategy, if we would add a new file, it automatically inherits the default enable. So we must immediately build it with nullability in mind and properly annotate our members and parameters. A second strategy would be to do it a little bit less aggressive. So we could keep the default, which is nullable disable, and then every time we want to make a file or a type nullaware, we then explicitly add the nullable enable, start annotating, start fixing warnings until we are done, which would mean each and every file has the nullable enable on top of it. So then we can enable it on a project level and remove all those now redundant nullable enables. So the drawback of this method is that new files still inherit the default nullable disable. So we would need to explicitly add it in order to have new code already adhere to the nullable context. But I guess this depends a lot of the team and of the project of what the best strategy is. Now, this only works if we require C#8. The thing is, if we have a .NET Framework project or a .NET Standard 2.0 project, officially C#8 isn't supported. The default language for these projects is C#7.3. So nullable reference type aren't enabled. We need to explicitly set it to C#8. This is not officially supported by Microsoft. Most language features still work. There are some which don't work. I believe it's default interface implementations. And the other issue is that these frameworks, .NET Framework or .NET Standard and below, which is, for example, also .NET Core 2.1 or below, but yeah, they're out of support by now. We don't have those nullable attributes, but there is a package for that. Let me briefly show this. NuGet.org. It's by Manuel Römer, the Nullable Package. And this package now adds those nullable attributes that I showed before. So all of these, such as allow null, disallow null, or the member not null, does not return, all of these are added by this package to non.NET Core 3 compatible projects. So we can add this to lower target frameworks and then have those attributes at our disposal. But another issue that we would face with not higher BCL versions is that neither .NET Framework nor .NET Standard is annotated with nullable reference types because the C# feature didn't exist there. They are oblivious, so we don't know about the nullability. What we could do is multi-targeting. So we could, even though we only want to emit a .NET Standard 2.0 library, we could do multi-targeting. For example, still emit the .NET Standard 2.0, but also have a .NET 6 build. .NET 6 is fully annotated. The entire BCL contains all nullable annotations and all the attributes and everything. So we would get all the warnings for .NET 6. So if we have warnings as errors, we would get our nullable annotations and nullable warnings right. But with .NET Standard 2.0, since it's not annotated, we kind of need to ignore those warnings. So for that, where do we have this example? There it is. For that, we can say, actually this belongs down here. We can say, hey, if the target framework is .NET Standard 2.0, then we want to not emit any nullable warnings. And there is a bunch of, I'm not sure, is it 10, 15, something different kinds of nullable warnings that are associated with the nullable reference type features. We can ignore all of them with the, if we just say nullable here. So this is a set of all nullable warnings. So for .NET Standard 2.0, since it's not annotated, the BCL isn't annotated, arguing about nullability is difficult, but still all of our types would be annotated with the nullable reference types because we enabled it on top here. And consumers could use correct annotations. And the .NET 6 build now ensures that, because .NET 6 is fully annotated, we do not suppress the warnings there, and we would get warnings if we don't have something set up correctly with the latest annotations from the .NET 6 library. Down here, I have the example how we could include this nullable package so that we get all the nullable attributes. Keep in mind to have private assets for these, also that this dependency isn't transitively inherited by consumers of this project, so that it only refers to this project only. And another part is now to think about argument validation. So if we would have all of our methods annotated, do we still need to check for null? So I'll just go to the program. Let's say we have exactly here, we have a method where we can pass in the instance. And usually we would do before .NET 6, before .NET 8, since it's before C# 8, since it's a public method, we should check if this is not null. So if it is null, then let's throw a new argument null exception. Actually, argument null exception. Or alternatively, now with I changed it to struct. Sorry, yes, this should be a class, of course. Alternatively, with the .NET 6 BCL, we can say for if null. Pass it in here. So do we still need to do this? Because I have annotated this as not null. So the caller now would get a warning if the caller would say null here. So this could be in a whole different project because I published this as a NuGet package. Now the caller gets null. But we are not sure that the caller actually, since it's per default still not enabled, or it could be an older version of the compiler, so the compiler doesn't even know about nullability. We can't rely on that. So we still should, all of our public methods, we still should do null checks in order to give throw as early as possible that a method received null, although it shouldn't have. But for internal methods, we could, and especially for private methods, we can now emit the null checks, especially if we have warnings as errors. This could look like, where do I have it? Warnings. I believe I have it in the directory build props. Yes, there it is. So what I usually like to do is, in general, treat every warning as error in release configuration or in non-debug configuration, how you would like to form it. But since it's about all or nothing, null and void, we can also just enable the nullable warnings. So in release build, all the nullable warnings now become errors. So for internal and private methods, if we would pass null to it, we would get, we couldn't even compile in release. And since we know that the private methods and internal methods can't invoked by another library, well, they could use reflection, but yeah, that's kind of on them. Then they just can't get the language features if reflection is used. And yeah, so every externally visible method should still validate the arguments for null. Now at the end, I would like to talk about alternatives to null. We could, for example, here we have a method which returns an enumerable, but we return null. Now, what's a null object? A null object is an implementation of something, an implementation or deriving an abstract class, which basically does nothing. So all the methods try to do as nothing as possible or as falsy as possible without any side effects whatsoever. And with collections, this could be either array.empty, in that case string, or enumerable empty, which is in the link namespace. So it's a empty enumerable, which when we for each it does nothing. It yields no element. Now with tasks or with async methods in general, we should never return a nullable task, because the caller, I would never expect that I need to check the task that I want to await via the async the await combination to null check it before I actually await it. This code would look weird. So never return null for a task. If I want to say that this method isn't async, I can return a completed task, task.completed task, which is just completed. So there is no side effect. The await sees, okay, this task is already completed and synchronously continues. So no side effect. If we have a task of T, it's fine. It's okay to return null as the result of a task. In that case, this would be then task dot from result. So it's fine to return null as the result, but never return null as the task itself. And with cancellation token, since it's a struct, you can just say default, but there is also cancellation token dot. I'm not sure actually. Is it default? I don't have auto-completion here. Cancellation token dot. Now I embarrass myself. Is it dot? Oh, I need to look it up. Cancellation token. Properties. None. There it is. Cancellation token dot none, which basically says, okay, it cannot be cancelled. Now, if we would like to use the null object pattern ourselves, I have here an example of implementing a null logger, which does nothing. So I have here from Microsoft.extensions.logging the iLogger interface. It expects us to implement begin scope. Now begin scope returns an iDisposable. So I need an iDisposable, which does nothing. So down here, I have the null disposable, which implements iDisposable. And its dispose implementation, it does nothing. Now we see that with null object patterns, they shouldn't have any state, they shouldn't have any side effects. And then the singleton pattern comes in very handy, because we don't need to instantiate a lot of instances of the same thing which has no state and does nothing. We can reuse a shared instance. This also saves pressure on the garbage collector. And for the other methods of the iLogger, and then we return this instance for this begin scope, but we don't do anything else. iLogger also forces us to implement is enabled. We would say false. So because this is the most nothing we can get. And then the actual real log method, it again does nothing at all. And here again, the singleton pattern comes in handy, because there is no state, there is no change. That's a nice fit. There is also optional types. So they have been very popular before the C# nullable reference types. Well, nullable of T is some sort of an optional, but we could also have a look at other optional types which are not constrained to struct. So for example, we could have this optional. This is actually from the Roslyn library. So this is now, well, the optional itself is a struct, but it's unconstrained. So we could pass in anything, value type, reference type, what we want. It's very similar to the nullable struct. And we can expose a method has value and then actually return the value. So the consumer could always check, does it have a value? And if not, we can then use the value. So this came in if you want to declare optionality before C#8 nullable reference types. There's also a library one-off that I found where we could, for example, have a type which is either an apple or an orange, and then depending on what it actually is at runtime, then do certain things. So we have some sort of a fancy switch, basically, depending on the type that it actually is, or also wrapping a null. So this is how we could also, with additional types, prevent null in the first place, if we don't want to use it or are in a certain place where we can't use the C#8 nullable reference types feature yet. And this sums up everything I know about nothing. I have a brief look at the chat. Was there a question that I've missed?